Okay, hi. So, welcome everyone. Let's do some Kotlin. Now, if you don't know what Kotlin is, let me just give. Okay, hi. Hold on. I seem to be having everyone. There we go. I accidentally was watching myself stream in another screen. Okay, so language we're using today is Kotlin. It's a statically typed. You can read. It's a neat language. I like it quite a bit. So yeah, and what we are implementing today is it's a little pet project of mine. It's a game, fine, yes. It's a turn-based strategy game based on an actual board game, but it's really in its infancy and it's nothing serious. I just like hacking on it from time to time, which makes it sound like there's actually something to look at, but there's not. I promise you, there's not. Okay. Yeah, so check out Kotlin. You're checking it out now. Okay. Okay, so maybe I should tell something about the board game. Yeah, let's do that. So, if you haven't already, check out a game called Skirmish Tactics Apocalypse. It's a really neat 2 to 4 player skirmish battle game set in a post-apocalyptic future. It's easy and quick and fun to play, and yeah, it's really neat. So check them out. It's free to print and play at the moment, but there's an actual physical game coming out at some time in the near future. They have a publishing deal already and so on, but yeah, it's still free to print and play. Okay, so what I've done here is this here is my Kotlin project. Ignore everything except the module called domain, which holds the, well, the domain of the game, which is to say the game data and the game rules. And what I've done here is that I went and implemented just the move rules, and let's see if I can find a. Yeah, I have a bunch of unit tests which make sure that I have implemented the rules correctly, and some of them even print. I'm so proud of this. Check it out. I'm too proud of it. The tests print out some ASCII art to standard out, which shows the board state. For example, here we have a figure alpha, which can move to the spaces designated by this character. I know it's crude, it's simple, but it works, and yeah, it was quite fun to implement. Okay. Yeah, so many of the movement rules are actually implemented already. I don't know if I should be showing this. I don't know how interesting this is to see the results of past unit tests, but hey, what else? So let's go to my Trello board here. Ignore this word. There's no REPL. No REPL. So yeah, what I was going to do today was implement some of the turn structure rules. And yeah. Oh, look at that. I was on mute. I mean, I wasn't, but I had that text overlay. Okay, it's fixed now. Okay, so let's get cracking. So during the implementation of the movement rules, we have already introduced the concept of teams to the data structure. And let me show how that is. We have figures, and they have. Okay, yeah. Let's fix this. Okay, I dislike the idea of having string IDs. I'd prefer to have an actual ID class. So let's do one. I can, at the same time, I can show one neat thing about Kotlin. Let's just make a new Kotlin file. That's fine. Call it a key or ID. ID is fine. Yeah. Yes, let's add it to a version control. Okay. Okay, one thing. You know how in Java, I'm gonna keep comparing Kotlin to Java. I'm sorry about that, but that's just how it is when you are streaming Kotlin. You know how in Java when you write Pojo, you have to write all the getters and setters. Okay, that's fine. You can generate that, and yay. But then one field changes, and suddenly you have to change these setters and getters and whatever. But in Kotlin, we have a concept of data class. Let's call it ID. And then we specify that it has an ID string, which is a value, meaning that it does not change. It's making ID immutable. And what happens here is that getters and setters are automatically generated behind the scenes, so to speak. So that's it. Let me show you my data class figure. It has 5 fields, and all of the getters and setters are generated automatically. So that's neat. In addition, I have an alternative constructor here and an utility, I mean a member method for the data class, but this is all that had to be done. And let's see, this is now an ID. Yes. So is this, and also this. Okay. Right, okay. And this is a constructor for unit tests where the team can be whatever. There should be errors elsewhere, but we'll get to them in a minute. Now let's introduce, since we are going to need the concept of players and teams in today's coding session, let's introduce a new file, yes, called players. And one neat thing about Kotlin is that you can have several classes in a file. So the players and teams are so closely knit together, or at least they're so close to each other in some sense that I'm just gonna push them to the same file and be done with it. So we have the concept of player. Players have a name, fine, yeah, sure, why not? And they have a team, which is an ID. And then we have team, which has a name. Why not? Okay, well, this should do it. Okay, and finally, let's game state abstract. Why is this in abstract? Shouldn't this be in data? It should. Okay, let's see. Can I move it? Move game state to package data, file name, game state, that's fine. Yeah, okay. And add it to version control. Excellent. Okay. Okay, game state. Actually, I have to refactor this at some point, but at the moment, it takes a gamescape, which is the playing area, the board, and it takes here. Now this is a neat thing. And if you have not done anything with Kotlin, I do not expect you to wholly get this. This is a horrible example, but it's an extension function to a mutable collection of figures that does not return any value. I mean, it returns unit value. Yeah, it's not neat. But the idea here is that you provide a closure that initializes the figures. Now, this is very handy with unit tests, but I don't know if I'm gonna keep that way for too long. But let's not worry about it right now. Let's instead let's have here a collection of players. Val players. Now, in Kotlin, you specify the type of a variable or parameter after the name of the parameter, which is just wonkers to me still, even though I've done quite a bit of Kotlin already, but I still keep tripping over that. But that's fine, that's fine. Okay, so in a game state, we have the scape, we have the figures, we have players, and of course we have teams. Collection of teams. There we go. And now all of our code should break. I won't add any assertions or validations to the data, at least not yet. Maybe at some point. And can I refresh these somehow? You may notice that I am not very versed with IntelliJ IDEA, which is kind of a bummer, but I know that there should be compilation errors. Do I have to inspect the code? Maybe. No errors though. Oh my, that's a lot of warnings. I should clean this up. Okay, no. No. There. Okay, fine. We'll just go them over file by file. That's fine too. So let's There we go. Let's, for the sake of the unit tests, specify a default value for these parameters. Now that's another cool thing about Kotlin. You can have default values for arguments to constructors or functions or whatever. Yeah, it's really cool. And as you can see, you can have named parameters. You just say, hey, this is Cape. Okay, figure needs the, oh right, the ID. Nope. Control B, oh right. Yeah. Yeah, right. What's happening? I don't know. Yeah, we have to. Actually, just to save some trouble, let's define another alternative constructor that does that automatically for us. Now, if this somehow is a bad idea at some point, I'll refactor it out of off camera. Okay, anything else in this class that has to be type mismatch? Oh, right, yeah. Now, since I added the new parameters to the constructor, now I have to do this, which makes me wonder if I should create an alternative constructor to this as well. I should. Let's see, a Gamescape and figure init. Oh, thanks. And okay, I promised you that I would be reading the manual, I mean the Kotlin language reference, and so I shall. Ah, there. Okay, so this is the alternative constructor. It has to call, I believe it has to call the primary constructor. Okay, yeah, and it can have a method body. Cool. So let's call escape empty list and figure init. Oh right, and these are not actually values for the class, but instead a constructor. Sorry, constructor is actually a method, kinda. I mean, it's not. It's a constructor. Whatever. Moving on. I'll just dig a deep hole to myself if I try to correct myself too much. Okay. And what's happening here? String coordinates. Oh, right. These are defining the team. So let's one more with the team as a string. Team. There we go. Now this works as well. And there should be no more. And we can run all of the tests and see that something broke. Right. Oh, one thing I did not tell about ID, which is, one thing I didn't tell you about data classes. It generates the getters and setters, and it also implements hash code and equals and a sensible to string method all automatically without any programmer intervention, which is heck cool. Okay, here's one thing that a bit bugs me, is that the IDs used to be strings, which, let's face it, it's not a very good ID class for an ID. There's no type. But now we have just changed a string into an ID, and ID again is just some kind of type. Okay, sure, it's an ID, but you don't know what kind of an object has that ID. So, right. Kotlin type parameters. No, not inline function. Dynamic types. Oh, I'm an idiot. Kotlin generics. There we go. Oh, it's just like in Java. Fine. Target type. Now that's a really long. So let's just use T. Okay, and here's one thing that I really should check out how it's supposed to be done. You know how in Java you have a Java doc, which you should be writing for your methods and classes. It's a blanket statement, fine, but in Kotlin there's kdoc, and the syntax is not the same, which is fine, but I haven't gotten around to actually learning kdoc yet. So let's see if we can quickly find. I believe it's in tools. Yeah, documenting Kotlin code. Kdoc syntax. Ah, there we go. Bottom T. Type of the target that has this ID. Excellent. So now we can go back to figure and change this into, figure ID, and this here is a team ID. Yeah, this is kind of cool. Figure and do I have to specify the type here? Maybe not. The type inference, I believe that's the word. Type inference in Kotlin is actually pretty good when compared to, say, Java. I mean, Java improved it a lot in Java 8, but there's still a couple of places where it sometimes surprises. Okay, let's continue. There's this constructor is never used. Well, let's ignore that. That's fine. Okay, and players team ID. Yeah, team should have an ID as well, right? It's only fair. Should we have a player ID? Not until we need it. We'll add it when we need it. Movement, there's some errors. Okay, let's close these so we can. Okay, this I'm sure looks horrible at first glance. This is the mm, the meat of this project at the moment. Find path. It finds all of the possible squares a figure can move to during its turn. And I mean, it's not overly complicated. I'll come back to that in a minute. um, but it is quite large. But there's a lot of rules to cover. And I should point out that I try to keep some separation of concerns here. For example, if a figure has special movement rules, for example, there's a figure that hovers above ground, so it is not hindered. Its movement is not hindered by difficult terrain, and this special ability is not implemented in the movement rules. Instead, the movement rules pass on the calculation of movement point costs to the figure's abilities, which then, if there's special rules, they modify the calculation. So that once I have the game rules pretty much done, I can then shut down the files and just implement the abilities elsewhere. That's the idea, at least. And with that kind of flexibility comes some complexity, of course. But that said, there's still a lot of places that you could optimize here. Definitely, it's not optimal code, and it's not trying to be. Okay. But yeah, we were correcting these new errors when we converted the string IDs into ID types, which was an excellent idea. Team. Maybe I should. Yeah, why not? There's. Oh, there was quite a lot of arguments to that method. Okay, let's see. Adjacent figure IDs should be a set of figure IDs, and this should be also a set of figure IDs. Excellent, and that cleared all of our errors. There's one. Variable f is never used. Oh. Oh, right. This is just a minute. Okay. Yeah. There's if you play D&D, there's this rule called attack of opportunity, which means that if you are in close range combat with an opponent and you try to move away from them, you the opponent can then make an attack of opportunity on you. It works like that in D&D, and there's a very similar rule in Skirmish Tactics Apocalypse, and I call that the attack of opportunity rule in the code, because there's no actual name for it in Skirmish Tactics Apocalypse, I think. Oh well, this is easy to remember. what this means. Yeah, so let's ignore that warning as well. I'm ignoring all the warnings. That's a good sign. Okay. Was that all? Can we now run all of the tests successfully? No, not yet, because this should also be an ID of figure. How about now? All of the tests ran successfully. Okay, let's just make a commit. Refactored string IDs to an ID type. Yes, yes. Okay. And where were we? Right. I introduced the new data classes player and team with the idea of right. Turn structure rules. A quick overview on the turn structure rules. The game is played in rounds, and each figure gets one go each round. And on a player's turn, they get to activate 2 different figures, and then it's their opponent's turn and their turn, and then until every figure has had a go. There is an initiative rule that lets the player who won the initiative to have their option to do 1 activation or let their opponent start a round, which is kind of neat. And yeah. And passing with a figure, meaning that you don't take an action, is considered activating the figure, which means that it does nothing but be passive that round. So something like that. So let's think about it a minute. And the information whether a figure has had a go, is that part of the figure, or is it part of the game state in general? I could argue that it's an attribute of the figure. Yeah, it should make things a bit easier if we do it like that. So and since at instantiation time, did I pronounce that correctly? Maybe I did, maybe I whatever. Since at creation time the figures has had and go is false, so I mean it's a fixed value. It's always the same when you create a new figure. It's not even part of a round yet, so the value is always the same, so it's not part of the constructor. Now the question is if what's wrong with this boolean? Never used, okay. Oh, right, yeah. They're all public by default. Okay, so is activated the best? I'm also trying to think if um, yeah, that should be fine. Yeah, that's fine. Okay. So once every figure in the game has been activated, the round ends. They're all activated, status is set to false, and we start all over again. Okay. Right. And then we have the question of current player. Since there can be only one current player at any time, I'm going to argue that this information is best suited to the game state. This makes it so that there can never be a state where for some programming error several players are having a turn at the same time. I mean, that's cool. Okay. Current player, and we use an ID of the player. And what's wrong with this? Must be initialized, right? So one cool thing about Kotlin, this is a Kotlin commercial, but yeah, one cool thing about Kotlin is it offers a degree of null safety that can't be achieved by with Java alone. Meaning that with Java you have to read the Java doc of the method that you're using very carefully to know if it can return a null or not. And even in local code, local to your method, you have to keep sure that you are not referencing a null pointer by accident, and these accidents happen, as any Java programmer knows. And Kotlin has this cool thing that no reference can be set to null. Absolutely none. Except if it's specified that it can be set to null with a question mark. I like that question mark. It's so cool. It's like it's an ID, maybe. No, I think that I've been over this in my previous stream, which had some technical difficulties, but I think that I talked this through there. But yeah, we have a current player which is set to null, meaning that at the start of the game no one is in turn. Now, will this being nullable become a problem at some point? Maybe. But we'll cross that bridge when we get there. Okay. Okay, and since actually in a round there's some other information as well, so let's introduce a new data structure. data class round. Let's see if this makes any sense. This might actually make some sense. This might actually make a lot of sense. During a round, someone is always in a turn. Let's see. I always write the type first. Player order. Is there an ordered set? For some reason, ordered set. There is one in libgdx's utils. Let's check it out. Fine. And this. Yeah, the first value is this. Let's create a. Should we? One neat thing here is that we can actually omit the type declaration here, because Kotlin knows that we have a list of ID players, so this is going to be a player ID. Right? Maybe. Okay. Let's see if there's what does single to? Returns the single element. Oh, cool. Kotlin introduces a lot of new neat extension functions too. Hold on. There's someone in the chat. Hello by satellite. Hello to WatchMeCode on Reddit as well. That's it's a really neat subreddit. Check it out if you haven't. And by satellite writes that I'm paraphrasing here. It's interesting to see someone stream Kotlin. If I'm indeed one of the few who does, I apologize for not being very fluent in Kotlin, but I do enjoy Kotlin and I do recommend you check it out. Yeah, hi by satellite. Okay, so I was just browsing these extension functions to list if there is some that does exactly what I want, but I guess that's not the case. Okay, fine. Yeah, let's just do it the easy way. We take the index of current player from the player order list. Does Kotlin's integer have an increment operation? They don't. Oh, right, because it has to be variable, not a value. Of course. And let's see. If E is greater than or equal to player order size 1. Math is hard. Then 0, else I plus 1. Okay. And the new current player is player order I. Yeah. I don't know if I'm going to write any unit tests yet for any of this. This was just a quick distraction. Okay. Okay. So during a game round, we have a player order. When we create the round, we have determined the initiative of the players, so we know the list of players, and the first player is going to be the current player at this. The current player is going to be the first player, and let's okay, let's think about this for a minute. Let's draw a picture. So let players be A and B. So in that order. So the turn structure is A, B, B, A, B, B, A, B, B, and so on. Or it's going to be baby A, B, B, A, and so on. The first player can pass their turn, the first turn, which is a shortened turn. Now, also, I'm going to quickly check the game rules here. The game rules about multiplayer. There's no there's no what's it called, clarifications on initiative for 3 or 4 player games, so I'm just gonna wing it for now. That's fine. So let's just assume that only the first player gets the advantage of being able to skip their first turn. Okay, so should I make an infinite stream of these, or let's create let's take our minds off that and implement an easy peasy function called are all figures already activated, and we demand a game state. Actually, let's demonstrate extension function. I'll write this out. Oops. Here, oh, sorry. Here we go. Okay, this here is a function that takes a single argument, which is of type GameState, and you can see these in Java code all the time. This is the way you kind of have to do extension functions, so to speak. And you'd call this R all, and you pass in your game. But in Kotlin you can do this, which is super cool. Now that's an extension function to GameState, and you have your game object, and you can ask R all blah 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 blah. Okay. This is not very exciting here because GameState is a class that we own. We could easily add that function to that class and be done with it, but you can write extension functions to any class, which is very useful. You could implement your own stream operations to the Java Stream API and use them in Kotlin, or I don't know, whatever. But yeah, let's implement this super simple method GameState are all figures already activated, which of course returns a boolean. So GameState, we take the figures, which is a collection of all of the figures on the game board, and we want to find does this return only one? Returns the first element matching the given predicate, or null if no such element found. Okay, so we want to find a figure that has not been activated. Right? Is there a find that returns a boolean? I mean, I'm not interested in the figure object. I just want to know if there is one or not. What is first null? Returns the first element matching the given predicate, or null if the element was not found. How is that different from find? Returns the first element matching the given predicate, or null if... Oh, first or null is an extension function, or it's a function of list, and find is a function of iterable. Interesting. My gut says that there's no difference, but by satellite writes and makes this a pair programming session, which I'm totally fine with. Since find returns a figure question mark, I mean a nullable figure, could you check if the result was nothing? Yes, of course. Right. Which is as simple as this. Is null. So thank you, by satellite. We go through all of the figures. We find the first that is still not activated. If we find nothing, meaning that this returns null, then all of the figures have been activated. So yay. Great. And yeah, okay. I mean, this is what I like about Kotlin. This after a bit of brain exercise, This was really, really. I mean, just look at it. Just look at it. It's so concise. I like Kotlin. Um, okay, cool. Okay, let's write a unit test to that, so that I can sleep at night. And this is game state, so it's in the STA domain data package. Let's add a Kotlin file. Game state test. Yes. This is something that I have not yet quite grasped about Kotlin. Since it's a JVM language, classes are they are structured into packages, which in Java translate to directories on your file system. So, for example, this file would be in directory STA, which has a directory domain, which has a directory data, and this file would be there. In Kotlin, you don't have to respect the package declaration with where you put the file. And I'm having trouble accepting why you wouldn't want that, but I've done Java for years, so maybe it's just that old habit which I am going to respect here and not try to change. But yeah, I'm open to any insight into why you would want files from different packages in the same directory. I mean, there has to be a good reason. Maybe in the Kotlin forums there's a thread for that. I should check that out. But yeah, well, let's do a test class. And now I use JUnit, which is de facto a unit testing library for Java, and it works just fine with Kotlin. We annotate with what's wrong with this? Oh, right. Jesus Christ, I'm so tired. Of course, it's an annotation for method. Of course. Test all figures activated. Okay, so let's create a game. Game state there. It takes escape and immutable collection extension method, extension function that initializes the figures. That's what we are going to use here. Okay, so let's create a new empty gamescape, just 0 by 0, that should be fine. And then, what's wrong? Right. You might guess that I do Java my day job because I keep writing Java here. There's no new keyword in Kotlin. Okay, and let's initialize a couple of figures. Let's take the objects out so we can easily change their state for testing purposes. F1 is a figure. What's okay, so it's ID, shouldn't matter. Location, let's oh, I have a shorthand function for creating coordinates, and then the movement allowance, and yeah, we're fine. Oops. Let's create another, and another. But we should be fine with 3 figures. And now the game does not currently make sure that the figures are, when the game is set up, it does not validate that all of the figures are placed inside the game board, I mean the game area, or that they do not overlap. So, but at some point it might do that validation, so I'm not gonna break future code by making deliberately illegal situation. Can I add... Oh, whatever. Let's just... This is fine. I should rethink that figure init anyways at some point. It's not very pretty. Okay, and then assert true. Assert... Can I use this? Let's see what this does. This should fail, right? I hope this does not use... right, this uses assertions. Okay, fine. Let's use the JUnit method, so that if we, for some odd reason, disable assertions, that we then accidentally disable this test. Okay. Multiple choices. There. Yes, that's the correct one. And assert true. And there we go. Okay, and there should also be assert false. Yes. Okay, so game, are all figures already activated? Should of course be false at the start of the game. F1 activated is true, and F2 activated is true, but this should still hold true. I mean, it should be false, right? And then F3 is also activated. I mean, this is not very very interesting, but this has to be done. And game, are all figures already activated? I mean, it's so simple. There's nothing that could go wrong, but you know, test-driven, at least in some sense. Figures can be activated. That's cool. Okay. Okay, now for something completely different. Hold on, let me grab my trusty notebook. Let's implement a tiny bit of math, because math is always fun. And this is actually a Kotlin file that I meant to look at today, so why not now? Because I actually have something in mind for this. So in Skirm's Tactics Apocalypse, you throw dice to resolve if you hit with a punch or shooting or whatever, and the game uses 10-sided dice. So we have an interface called randomness in the game that defines these functions, defines a roll function. You can specify the minimum and maximum for the die that you're rolling, but the default values are shown here. It's 1 to 10, the standard 10-sided die. And also there's flip, because I think that I'm going to want a flip function. I don't know why. But yeah, it's true or false. And as a reminder for myself, I added a copy function that... Oh, sorry, I have to take this. Okay, sorry about that. When a friend calls you at 11 p.m., you answer. Okay, so yeah, where was I? Right, the randomness, which will be an object that gets passed around in the game to provide randomness. It also has a copy method to bring you an exact copy of that randomness. This I wrote here as a reminder to myself that when I'm implementing AI, I can do... I mean, the randomness provides a way to implement a cheating AI. It can make a copy of the randomness and peek what results are there. So yeah, full disclosure, if at some point in the future I'm going to release this game, if it's going to utilize a cheating AI, I think I'm going to make a joke about it. It's a I don't know. You know, like in Chess Master game series, you have these different AI personalities with different rankings, and at the top of the tier there's this chess master dude with the long beard, and it has like over 9,000 ranking points. Oh my god, I just made an over 9,000 joke. But at the bottom there's Charlie, the chimpanzee, which is a really neat AI. The different AIs have different personalities. Some overvalue knights, some overvalue rooks, some ignore queens, and so on. But at the bottom of the ranking tree, there's Charlie the chimpanzee, which is an AI that does legal moves, but they are randomly chosen. Playing against Charlie is interesting. And if you can get a copy of Chessmaster, check it out. It's cool. It can give you ideas to all sorts of things. I believe Chessmaster 9000, I believe I had that one as a kid. So if I ever get to the point in future where I'm implementing artificial intelligence for this game, I mean, it's the game AI. I could make a cheating AI that knows the future of die rolls, which would be neat. Also, this might be useful when doing Monte Carlo kind of AI, which is kind of cool too. I mean, it would be kind of deterministic Monte Carlo. I have to do a proof of concept of that. No, never mind. But yeah, and also it just could be useful. You should never implement something just because it could be useful, but whatever. I mean, I'm going to implement a cheating AI that knows the future of die rolls. And this actually provided an interesting thing. The random class in Java, whoops, random. This one, Java util random. Oh, yeah. Accept, yes. Here. If you've done Java coding, you know random. You can create a new random. You can even provide your own seed so that you know that for a given seed, the sequence of random values that it produces will be the same. Fine. Okay, you know about how pseudo random you know how pseudo random number generators work. I should go to sleep. But yeah, you can't make a copy of it. You can't ask what the current quote-unquote seed is at the moment, what it's going to feed back to the random algorithm, which is kind of a bummer. I can't, without either using reflection or some hocus pocus state key bookkeeping, I can't make a copyable randomness with the help of Java util random. Prove me if I'm wrong. Okay. So that's kind of a bummer. And also there's also a random class random in libgdx's AI extension. Now I'm using libgdx for the graphical interface of this game, but I have not done I've done practically nothing there. I've just been focusing on the game rules, which I find interesting, but that's just me. So yeah, the libgdx random, I think it works kind of like the Java util random. I don't know, but I decided to use this one because you can copy the state of this randomness implementation, which is the Apache Commons RNG library has this. Yeah, check it out. So yeah, there's nothing interesting here in the implementation. So let's just go to what we came here to do, which was to implement another kind of role. And the other kind of role that we are going to implement is an opposed role. Yeah. Now, this will be a bit interesting. In Skirmish Tactics Apocalypse, I don't know if they use the term opposed role, but there is a concept of opposed roles, which means that two players, or at least two players, roll dice and apply their respective modifiers to the die rolls, and if there is a tie, they re-roll ad nauseam until no tie is rolled, which in practice works fine. But since I take it as a challenge that how could I implement a method, no matter how ineffective or slow or whatever, could I make one that does it in fixed time, meaning that there will be no rerolls. And while commuting, I decided to do it on craft paper, and yeah, it's actually not that hard of a problem, really. But it was interesting, to me at least. Let's implement it in code together. Okay, 1 hour and 18 minutes into the stream, and now I'm implementing something that I'm really excited about. And it's a small math function. Okay, let's go. Okay, so we have an opposed role, and let's just implement the simplest possible version of it that we can muster. Let's write some kdoc. Does an opposed role so the simplest possible version of this function will feature only two rollers. Let's extend this at some point to several rollers, but two is fine now. Let's keep it simple. Does an opposed roll guarantees no rerolls while maintaining the same odds as with the rules as written. Right. And then let's do this. Opposed roll results. Victor. Hmm. Hmm. Yeah. Is integer fine? It could be. I mean, I'm sure it's fine. Okay, so this will do the opposed roll, and it will return an opposed roll result, which contains the provided modifiers to the rolls, because why not? And the unmodified rolls, so that you can show in the user interface what die results were rolled, actually. And of course, Victor. And let's just document this, that 0 is first player and 1 is second. Let's use the word roller, because they not be players. Okay. I dislike this because it's not an integer, it's actually an enumeration, kinda. Yeah, because there's enumerated distinct values for this, but I kind of want to support unlimited number of fine, let's just implement this. We'll come to that later. Okay, and let's move this to the bottom. Now the the algorithm is super simple. Let's just see how neat we can make it in Kotlin. So that's kind of the thing that I'm excited about here. Let me first explain the algorithm here. I'm using a big fancy word algorithm, and it's super simple. You know, when you roll a die and then you roll another die, and you want to know the odds of, for example, what are the odds that die 1 is bigger than 7 and beats die 2. Okay, you draw a grid, right? You mark each column for the values of die 1 and each row with values of die 2, and you fill out every square in the grid, and you mark true, false, true, false, true, false, whatever the square is for that die roll pair. And then you count the total number of squares, you count true squares, and you divide them, and that's your probability. And yeah, that's without thinking about the problem and devising a neat probability function for your die rolling problem, you can kind of brute force your way to the solution that way. And that's neat. And that's actually how we're going to do it here. We populate a grid, and then we filter away all of the reroll results, and then we pick a random result. This should be fine. I think my math is correct, but prove me if I'm wrong. If I'm wrong, I'd be super interested to know why that is. My reasoning here is that for every draw result, you just do it all over again. So that should be fine. Yeah, but let's implement it like that here, and maybe I'll write to some math forum at some point. Yeah, I'll do that. Okay, so let's just make a naive version at first. Um, um, oh, and let's hard code the that it's a standard D10. So that's die 1, and that's die 2. Okay, and now we are in the quote-unquote the square of the aforementioned grid, and we have 2 die rolls. We could should we just map to these? Yeah. If D1 plus mod 1 is D2 plus mod 2, return null. No, not. A post roll result here, right? And let's move this to a variable in here, right? Yes. Let's be as cryptic as possible with our variable names, because that's always fun. If R1 is R2, 0, else 1. Yeah. And D1, D2, mod 1, mod 2. Okay. And then we filter not null and flat map. Oh, it's flatten in Kotlin. And then we pick a random one from that list. Introduce local variable, results, from 0 to result. There we go. Or is it easier to read like yeah, it's a bit easier like this. Yeah. And there we have it. That's the quickest, I mean, the naivest version of that algorithm that I could muster, and it looks very simple in Kotlin. So that was quick. I mean, this here kind of bumps that we fill the stream with null values for the ties, but I mean it's not too bad. Yeah. 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 I think you can agree with me when I say yeah. Yeah, this is horrible. 0, 1. No, no, I have to think about something. Maybe provide player IDs here. No, no, no. Mm. You know what? I'll sleep on it. I think this here is as good place as any to call it a night. Yeah, with some fun randomness function implementation. So yeah, I hope you had a good time. I had an excellent time. Thanks for anyone who popped in during the stream and for anyone watching this as a recording. And yeah, the current setup didn't explode, and I think that I'm still online. So, and there's no smoke anywhere. So I think I'll be streaming again at some point in the near future. So yeah, thanks again, and have a good night. Bye.